Hello there all. Hope everything is good with you guys. This is another video by yours truly, Cybersector Initiative Zone. Hope all is well with you guys and you guys are staying free and being safe. And I got another video for you guys today. And let's get right into it, man. We have a pretty good, interesting project to do. Give me one sec. Alright, here we go. So this is a project that I've already did, but we are going to do a project with Wireshark to analyze our very first packet within the Wireshark framework. So pretty much what we do is that we have to prioritize a type of lab per se in order to get the lab started within the Wireshark. So what we're doing is that we are having to analyze the network packet capture file that contains traffic data related to user connecting to an internet site, and the ability to filter network traffic using packet sniffers gathers relevant information that is a essential skill as a SOC analyst or security analyst. You must filter the data in order to identify the source and destination IP addresses involved in the web browsing, examine protocols that are used that the user makes the connection to the website, and analyze some of the data packets to identify the type of information sent and received by systems that connect to each other when the network data is captured. So as we are starting this, we are going to open up the Windows VM, in which I will, try to make this simplistic. But hold on, give me 1 second. Sorry, sorry. Um, yep. So basically, what I have to do is that I have to open up this tab right here to do my Windows VM, and what I do from there is that I have to basically open up Wireshark, and what I do is this: I have to basically double click on this file called sample.pcat. So once we click on this, this will give us a open box. Oh wait, hold on. I might need to go to Wireshark and actually put it in. Sorry. So I have to open up Wireshark. I apologize. Hold on. Give me 1 second. Alright, I'm back. So basically, what we're doing right here is that we need to run Wireshark on this file. If the file is not allowing you to open it because Wireshark is not installed on this VMware instance, definitely you need to install Wireshark on this VMware, and then you'll be able to proceed with the process. So just install that, and then once you have it installed, you double click this. This is going to open up, your file here, and right here you see all these numbers. You see a lot of code being written into the different column protocol sections where it shows you the number, it shows you the time, it shows you the source and the destination protocol length and info. So what we're doing right here is that we are basically analyzing data packets of what we are trying to see here. So it's saying for the very first task we have to open up the packet, and then after that we have to double click on the file, and then it's going to show us a lot of information. So it says a lot of information is listed here, and I'm not going to read through everything, but this is just everything that it's just giving you a overview on. So what is going to happen here is that you have to just look at the coloring rules of what these packets are showing. So basically, to make this simple, these packets have different types for the rules that are being written for the packet. And every packet that is shown within the source and destination IP address, it is displaying a certain type of protocol function to show the information that is being displayed for the basically for the data traffic that's being shown. So right here it says right here, not all data packets have the same color. Coloring rules are used to provide high level visual cues to help you quickly classify different types of data. And since different network packet capture files can contain large amounts of data, you can use coloring rules to quickly identify that is relevant to you. And then this just shows you example packets that contain DNS traffic, followed by green packets that contain a mixture of TCP HTTP protocol. And it says right here, scroll down to the packet list until the packet is listed, where the info column starts with the words echo ping request. So we have to just scroll down, and this is our very first record here that we see. I'm just going to highlight that. So we're right here. This is our echo ping request server, and it's asking us what is the protocol in the first packet where the info starts with the word echo ping request. Our protocol is most likely ICMP. I'm going to select that, and boom, we got that. So after that, we have to apply a Wireshark filter. So this isn't pretty difficult. All you have to do is basically find a certain specific IP address that you put into the filter. So it's basically saying that, with this code that we're copying right here, you take this code, you copy and paste it, Control V onto the filter, hit this arrow right here, and then boom, you have a lot more descriptive measures with the rules that you put in place within the search filter. Now, what is happening right here is that it's showing a lot of information that is a lot more easier to limit our, viewership to find the certain packets that we're trying to inspect. Now, it says double click the first packet that lists as TCP protocol. So we have this one right here. I'm going to double click this. And yeah, here we go. This is just giving us standard information of what we see on the screen. So with that being said, we have to go to the next step, which shows more details about, I guess like the AXI values and everything that you see, within the coding function. Basically, if I double click this is showing everything of like what's being recorded for this data packet. It tells you the encapsulation type, whether if it was like a wire connection or a wireless, type connection. Tells you the arrival time, UTC arrival, epoch arrival, time shift for this packet, time delta from previous record frame. So, it's giving you a whole bunch of information. And from what this project wants us to do is that we need to double click on the first subtree section that starts with the word frame. So, yep, so we do this, and then we have this information, like I said, that is shown. It has all the information that gives you everything that you need. So I double click that, and then it says double click frame again to collapse the subtree and click Ethernet 2 subtree. So I'm going to do that, and I'm going to double click Ethernet 2. This gives you all the information for a different line of data, that being the type of the IPv version connection, which is IPv4 or IPv6. This was a IPv4, and then it gives you destination IP and the source IP address, which this is listed right here, as you can see. So it's telling us to collapse that, and we need to move to the IPv4 version tree. So we're going to do that, and then we're going to double click that. And then right here is a little bit more descriptive, where it gives us a lot more information about our header, our flags, our time to live, a lot more deeper, information base of what we need to see. So we have to double click this, and then we collapse that, and then we have to move over to the TCP. Let's do that, and then let's just take a look at the data. Same thing. We have like a lot of information that I'm not going to just go over every single bit and piece, but you get the whole picture. We're inspecting everything out of this particular example within this packet, resource to understand what the main issue of our network packets that we're monitoring. So right here it just says, this just gives us detailed information about what we need to see, but it says right here, what is the TCP destination for this TCP packet? So let's just double click that. Our destination port is a port 80. Port 80 is usually used for web browsing or anything internet related. So that's always going to be the destination port for a port 80 packet. But for this case, we're just going to select port 80, because what happens if that was like a different port, that would probably be used for anything else, depending on what the issue was. So I'm going to click that, and boom, we got that done. So right here it says in the TCP subtree, we have to scroll down and click on the flags. So we do that, and we have to find flags. All right, we got that right here. So right here, it's giving us a bunch of information that I'm not gonna go over. That's gonna be a little bit too difficult. So it says all the packets have returned to the display. If you ever accidentally, okay, yeah, got that. So basically, what I was doing right there with the flags, this is just showing a detailed view of how TCP flags are set within the packet, because this shows right here that these certain set rule principles are different permissions that the flags were being given to the TCP packets to make it you know to make it strict within its rules for the operation to continue. So I'm just gonna get out of that, and then let's just go back here and put like a brand new filter in. So I'm going to copy and paste this, and then we are going to apply this filter once again, and then boom, we got that. So this is basically saying that we are going to request a filter from the IP source address that is going to be equal to 142.250.1.139, and that's our data that we're seeing right in front of us. So we click that, click enter, filter list is returned. It only brought packets that came from 142 blah 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 to 139. So we're going to clear this again, and then we're going to do a brand new search. We're going to do IP destination address for the same thing, and boom, we got that right here. So from this point on, we see that we have like a different line of information. And what this did is that this is showing a different filter list that contains only packets that were being sent out to 142.250.1.39. So we're going to click on the clear display filter, and we're going to do a brand new different filter, and we're going to add in the Ethernet address to see what different information that we may find. So we do that, you just copy that or just type it into the screen. See that right there, pause the video if you need to, and boom, we have that. And now we have like a different line of information that's sitting right in front of us. I'll just do that again. Boom, we got that. So we double click on the first packet that you see on the list. You may have to scroll back to scroll back to the displayed. Okay. Um okay, so yeah, hold on. Give me 1 second. So we are going to double click on the first packet in the list. Alright, the first one. So this would be this one. So let me do that. You may need to scroll back to the first packet in the filter list, double click on the Ethernet if it's not already open. Alright, so all we need to do is click on the very first packet on the list, and then we have to basically look at, hold on. Yeah, so double click that. The MAC address you specified and the filtered is listed as source or destination. Okay, got it. So all we have to do is just double click on okay, got it. So we just double click on Ethernet 2. Okay, got it. This is 142.15.1 to 142. Got it. Alright, I think this is what we needed to find. So I'm going to close that, and boom. We have to click on Internet Protocol subtree, and then expand it to time to live. Okay, so we get that, and then we have to find time to live. Got it. It's going to be time to live. The protocol in the IPv4 shows which internet protocol is contained in the packet. Oh, okay. Until time to live and protocol. Okay, so yeah, I need to just find out the protocol. This would be my data that I'm looking at right here. So, give me 1 second. It's basically what this question is asking is saying that what is the protocol contained in the Internet Protocol 4 subtree from the first packet related to MAC address? Yeah, so I already have it right here. It's TCP because it was already showing that to me once I found the very first packet out of this sample. Click that, boom, we got that. So we're going to hit X, and we're going to clear display filter. And then after that, we're going to use filters to explore DNS packets. So we do that, hit enter, and then boom, we got a new search. So we double click on the first packet to list, in the list to open up the packet window. So now we got that. We have to scroll down and double click on queries. So we have to scroll all the way down, And where's our queries? Hold on. I'm sorry. It's been pretty difficult to find this. Oh, okay. Got it. So we have to go to domain name system, and then we have to scroll all the way down and click on queries. And then you'll notice a site that is queried as open source. Click the X. Okay, got it. You notice that the name of the website was queried, which was opensource.google.com. Let me try click on that. Yeah, it's only just giving us basic information, but this is just telling us that the length, the label count, and the type A, which is, basically, listed as like a host address, and then class IN. I forgot what exactly that was, but I do know that this is just basically giving us like a broad, general description of what we're seeing within the Google, um, site. So we have to scroll down and click answers. Yeah, so we have to click on scroll down and double click answers. Got it. So hold on, give me 1 second. I'm very sorry. Yeah, it's like a lot of information, but it says you know, oh, okay. Yeah, so we have to click on the X icon to close the detailed. Oh, okay, got it, got it. Okay, so what we do right here is that we have to go to the for packet 1, 2, 3, 4. Double click that, and then after we do that, we have to go to yep packet, and then yep we have to go to domain name system to expand it once again. So give me 1 second. I have to just go to the domain name. Got it. So right here we go to answers, and boom, we have yeah, we have the information right here. So it's asking us which of these IP addresses are displayed in the answer section. Oh, okay. So we just have to look at this information right here with the IP addresses, and we see that we have different types of IP addresses that are shown. And this is just giving us like all of our different IP addresses that we have to see, but we have to match it to like what we see right here. So I'm gonna go with possibly the first one. Yep, 142.250.1.39, and all these three other ones are not really listed on the screen. So I'm gonna go with 142. Yeah, 142 to 139 IP address. Click on that. Boom, we got that. So after that, we have to use filters to explore TCP packets. Now this is going to be a little bit different. So I'm going to back out of here, click clear display, and then I'm going to use this code right here, put it in, and boom, I got my TCP ports listed in this search query, or Wireshark search. So after that, we have the filter. Quite a few packets were created when the user access to the page opensource.google. So it's telling us to double click on the first packet in the list. Okay, got it. Yep, 169. Yeah, 169.254.169. Okay, got it. So 169.254. Yep. So we're going to click on this one. This is going to be the one that we're going to be double clicking. Click on that, and then it's going to ask us of the time to live value of the packet that's specified. So what we do right here is that we have to find the time to live. So I believe we go here to not Ethernet, but I think frame. No, not frame. Go to TCP. I think it's TCP. Wait, hold on. Give me 1 second. I'm so sorry, guys. It's a lot of reading. Okay, got it. So I found it right here. You have to go to IPv4. Yep, you have to go to IPv4. And this is going to be our time to live, which is 64. So what is our time to live packet of the packet specified? 64. Hit that. Boom, we got that. And what is the frame length of the packet specified in the frame subtree? Um, right here we have to find the frame length. Now this is a little bit difficult. I think I know where to go, but hold on, I think I need to go to here. Yep, right here. Got it. So this is where you will find like the frame length out of your, particular packet right here. So packet number 37, 54 bytes on wire. So we hit on 54. Boom. And then it's asking us what is our header length of the packet specified in the internet protocol. So this is let's see. Uh yeah, you have the frame number right here. And let's see, encapsulation arrival. I think you have to click on. I think I need to go back here. Yep, right here. Header length is 20 bytes. So we hit that. Boom. Got that. What's our destination address in the IPv4 subtree? So our destination is 169.254.169.254. Yep. So yeah, this is pretty simple. You just have to just go through, these sections, and then you double click on the information that you're looking for, and then you will find your data a lot faster depending on what you're analyzing. So I click on that, and then boom, and then after that we just have to clear the filter, and yeah. So yeah, I think that's almost it. Hold on, let me just do that. I'm going to close this out, and then I'm going to clear that, and then I'm going to use the curl code to filter everything. What this does is that this filters to packets containing web requests made with the curl command and this sample packet, capture file. So yeah, I'm gonna do that, and then that's gonna be it for the video. So yeah, that's pretty much it. I mean, this is exactly what we're trying to look for. Basically, all that we were doing was that we were trying to investigate potential suspicious activity within TCP packets, and what we are doing is that we are finding the proper information to examine the packets and make sure that we see everything within the data layers to understand what we are, researching. But yeah, this is pretty much it. This is a pretty good, easy lab. But be sure to like the video, do what you have to do, and I appreciate you guys coming through. And yeah, stay safe, be free, and always be, you know, secure against all threats, foreign and domestic. All right, I'll see you guys. Thank you, and I will see you guys in the next video. All right, have a good day.